Hello, and welcome to Mathy Python. This episode looks at solutions to the problems about conditionals. Problem one asks you to write a program that asks the user for a number and prints whether it is positive, negative, or zero. So let's turn on lines. Okay. Let's run it. So input an integer, 67, positive. Enter an integer, I'll say 0. Enter an integer, negative 234, negative. So the first line gets input from the user, casts it to an integer. I did not put error checking in here. You could if you wanted to, but the point of the problem is the if statement. If the number is greater than 0, it's positive. If it's 0, then print 0, otherwise print negative. Without running it, first predict what this prints, then check. Grade is 95. If grade is greater than 90, print A. If it's greater than 80, print B. If it's greater than 70, print C. So let's see. The grade is 95. Is 95 greater than 90? It is, so it prints A. Is grade greater than 80? It is, so it prints B. Is grade greater than 70? It is, so it prints C. So the point here is that you need an else if. So you want to say if grade is greater than 90, print A. Then you don't want these other two statements these other two if statements to fall through. So you say else if, and that should fix it. So first to verify, we do in fact get an ABC. To fix it, just say else if, and then grade is 95. If it's greater than 90, it prints A. Else if, well, we've already done something, so these don't get run. Problem 3, write a program that takes a year's input and prints whether it's a leap year. Use the rule from episode 3's puzzles. So we got a year from the user, cast it to an integer. Is leap is the condition. It's divisible by 4, and it's not divisible by 100, or it's divisible by 400, and then you print. So 1900. Not a leap year. Let's say 1904. Oops. That is a leap year. Write a program that classifies a number as a perfect square, perfect cube, both or neither. Test it on 64, 27, 36, 111. Look in the math module. I'll give you a link. So here's the math module. You can look through that. So we want perfect square, perfect cube, or neither. So I got a number from the user, cast it to an int. Look at the square root in the math module. If you search for square root, there you go. Find it here. Returns the square root of x. That looks like that's what we're looking for. Okay. Cube root, I could look for that too. Cube root. Okay. Get some more, well, not much more information. Okay, so we know how to do a square root. We know how to do a cube root. This is close. That's because of the way numbers are stored in computers. We saw earlier there might be a little bit of garbage on the end. So you can check to see if two numbers are essentially equal. And if we look at that, okay, you get more information. Returns true if values A and B are close to each other and false otherwise. It tells you the exact tolerances. The default's fine for us. Okay, so let's try this with 64. And we see that it's a square root. 8 times 8 is 64. It's also a cube root. 4 times 4 is 16 times 4 is 64. And notice we used if statements, not in all three places, not else if. So it's perfectly possible that a number can be a square and a cube root. Tested on 27. Cube root. Tested on 36. Perfect square. Tested on 100. 100. Square root of 10. Square root equals 10. Try it on 11, and that's neither one. Number 5, write a conditional that prints even or odd for any integer. Test on 0, 1, 2, negative 3. So again, I get a number from an integer from the user. If it is divisible by 2, that's what that means. It's even, otherwise it's odd. 0 is divisible by 2, I suppose. 1 is not. 2 is. Negative 3 is odd. Number 6, without running it, predict what each prints, then check and explain. So true and false, you can't be both true and false. It's one or the other. True or false, you're either true or you're false, so that's true. Not true is false. True and true or false. True and true is just true. Or false, so that'll be true. True and in parentheses, true or false. So there's an order of operations with Boolean operators, which is parentheses, then not, then and, then or. So and is higher precedence than or. But now that I've broken that with parentheses, true or false is true. True and true is true. And does that play out? False, true, true, it does. Write a program that takes 3 numbers and prints them in descending order using only conditionals, not sort or sorted. So we're rolling our own sort method here with 3 numbers. So there are all the cases. There are 6 cases. So A greater than equal B greater than equal to C. A greater than equals C, greater equal to B, so forth. And then we try it with different test cases. And no matter what order we put these in, this is one case per case, they get sorted descending in the right order. So the point of that, sometimes you just make subcases. Problem 8, interest rates. A bank offers different interest rates based on the account balance. Under 1,000 is 1%, 1,000 to 9,999 is 1.5, so forth. Write code that takes the balance, prints the applicable rate and interest earned after 1 year. Test on a few different balances, including boundary values. Okay, so if it's greater than 50,000, the rate is 2.5. Else, if it's greater than 10,000, it's 2.0. So forth. The interest is the balance times the rate. And print that out. Try it on various inputs. Okay. So this will print out the balance, the rate, and then the interest. Problem number 9, write a password validator. Valid password must be at least 8 characters long, contain at least 1 uppercase, contain at least 1 digit. Print a specific message for each rule that fails. If all rules pass, print password accepted. Okay, let's look at the solution. So for the password, I input a password from the user. Set is valid equal to true. Then we'll go through the cases of what can make it not valid. And if it's not valid, we'll set this is valid to false. Okay, so in this case, I think it's easier to set is valid true, assume true, and then check to see if it's false. Is the length at least 8 characters? So I check to see if the length is not at least 8 characters. It's less than 8. Set is valid equal to false. Print out an error mess or print out a message of why the password is not valid. Check to see if it contains at least one uppercase letter. So I'll assume is upper is false and then loop through the characters, and if any of those are uppercase, then this is true. So is upper is false for character and password. If it is upper, then the variable is upper is true, breakout. And then check if that is upper has been set is false. So if not is upper, meaning if it's false, then say is valid is false. Print out a message. That should be in parentheses, not. Let's see if the password has at least one digit. So we'll set is digit is false. Step through. If any of these are a digit, then that becomes true. I'll loop through for character and password. If it's a digit, the variable is digit is true. We break out. Then you check if it's not is digit, then it's not valid. So is valid is false. Print out a message. And if it passes all that, then it is valid is still true, and a print password accepted. So let's try this with different passwords. Let's do one that's too short, but it is upper and has a digit. And it says password must be at least 8 characters long. Okay. Has to contain at least one uppercase letter. So that's long enough, but there's no uppercase. Has to contain at least one digit. Oops. Okay, so it caught that. It's long enough. It has an upper, not a digit. Okay, here's one that breaks several conditions. So password, just a little letter A. It's not 8 characters long. It doesn't have an uppercase. Must contain at least one digit. Okay. And now let's try 8 has a digit, and that one is accepted. Number 10, given x equals 5, y is 0, what does this print and why? And what would happen without short circuit evaluation? So if x is not equal to 0, it's not, so print A. This line says if y is not equal to 0, but it is equal to 0, so we'll skip this. Notice it doesn't go through and check all of this. Short circuits, we call it. So if y is not equal to 0, that's false. False and anything is going to be false, so we don't even need to evaluate this. If Python did evaluate, then 10 divided by 0, that gives a 0 division error. So your program would crash. So because of the short circuit evaluation, the program does run. So it prints A, y is 0, so it's not true that it's not equal to 0. So it stops right there, does not print B. All right, number 11 is the famous FizzBuzz problem. This was a famous problem for interviews, programming interviews. I think I've been asked this. Print the numbers from 1 to 100, but for multiples of 3, print fizz. For multiples of 5, print buzz. And for multiples of both, print FizzBuzz. So there's a couple ways of thinking about this. One is just check the conditions. So the trick here, if it's multiples of buzz, you want to print FizzBuzz. So if it's a multiple of 3 and a multiple of 5, then it's a multiple of 15. So then you print FizzBuzz, else, if, else. So these are skipped, and it will print it out correctly. If it's a multiple of 3, but not a multiple of 15, then it drops through this first if. Is caught in this case, just prints fizz. Similar logic for multiple of 5, but not multiples of both. So the trick here is to order these properly and check the both case first. So then 1, 2, 3 is a multiple of 3, not 15. So I printed fizz. 4, 5 is a multiple of 5, but not of 3 or 15. So it prints buzz. 15 is both, and it printed FizzBuzz. Another way to look at this is to build up the string. So for I from 1 to 100, say the result is initially empty. Check to see if it is divisible by 3. If it is, then result gets fizz concatenated to it. If it's divisible by 5, then it gets buzz concatenated to it. So if it's divisible by 3 but not 5, it'll just be fizz. If it's divisible by 5 but not 3, it'll be buzz. And if it's divisible by both, it's fizz, and then it's buzz. Notice that these are both if statements, not else if. And we get similar answers. 1, 2, 3 is fizz, 4, 5 is buzz, 15 is FizzBuzz. Number 12 is a triangle classifier. Given 3 sides, determine whether they can form a valid triangle. If it is valid, whether it's equilateral, isosceles, or scaling. If it's valid, whether it's acute, right, or obtuse. So I wrote some functions here. If it's valid, ABC. So I just check all that the sum of 2 sides is greater than the third. So A plus B greater than C, B plus C greater than A plus C greater than B. Classify the sides. If A is equal to B is equal to C. In Python, you can do this. A equal to B equal to C. That's perfectly valid. If that's true, return equilateral. Otherwise, if 2 of the sides are equal, it's isosceles. Otherwise, it's scaling. Okay, classify the angles. So I'll say ABC is sorted. I'll sort it out so that C is always the longest side. And then if C squared is equal to A squared plus B squared, it's right. If A squared plus B squared is greater than C squared, it's acute. Otherwise, it's obtuse. Then I have a wrapper function here, if classify triangle. So first of all, we check to see if it's valid at all. If it's not valid, return not valid. Otherwise, I'll return true or false for classify sides, true or false for classify angles. Then I'll run this. First one is scaling and right. Second is equilateral and acute, so forth. We can see that in line 37, that's not a valid triangle at all. And so it tells it's not valid and doesn't bother to check the other things. Collatz conjecture. Starting from any positive integer n, apply this rule repeatedly. If n is even, divide by 2. If it's odd, multiply by 3 and add 1. The conjecture is that you always eventually reach 1. Write code that generates the sequence from a starting number and counts the steps. Which starting number under 100 takes the most steps? Okay. So I wrote a function here. Steps is 0. While n is not equal to 1, we'll apply the rule. So if the rule is not true, then I guess we would get an infinite loop. This has been checked for numbers up to some astronomical range, but it hasn't been proven, mathematically proven. So it's possible that there's some enormous number out there that for which this will not be true. So we run while n is not equal to 1. If it's even, integer divide by 2, else you multiply by 3, add 1. Track the number of steps, so steps plus equals 1. If steps is greater than 1,000, we won't get an infinite loop because I broke out of it here. So if the steps takes some ridiculous amount, then we'll just break out of it, and we return the steps. So then I'll run it from 2 to 100, and check the maximum steps index. So if the number we get is greater than the index, then max steps is equal to that. So we'll say the max step index with Collatz of the maximum number of steps. That runs it through here and tells you how many steps. And the answer is 97 with 118 steps. Number 14 is BMI calculator. Given weight in pounds and height in inches, compute BMI using this formula. Classify the result as underweight, under 18.5, normal 18.5 to 24.9, overweight or obese. Print the BMI rounded to 1 decimal place and classification. So I wrote a function here with the weight and the height. BMI is that formula rounded to 1 place. Print it out. Look at the classification. Set that, print it out, and then I have some test cases here. BMI of 20, the BMI classification is normal, 22.8, also normal, 30.4 is obese, so forth. The last one is numbered to words. So given any integer from 0 to 999, printed in words. For example, 742 should print the word 742. Use dictionaries for the word lookups and conditionals for the logic. Okay, so I made a function here to find the hundreds word, 100, 200, 3. The tens word, which will be 10, 20, 30, 40, so forth. And then the teens, because you don't say 10, 1. 10T1, 10T2, that's not a thing in English. So it's 11, 12, and all that. Okay. So the ones word is the same as the hundreds word. So the hundreds word, just 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll also use that for 342, 347. If X is 0, just say 0. Otherwise, we extract digits. This is similar to a problem we did before. So the hundreds digit is X integer divide 100. The remainder is X mod 100. That gives you the remainder. From that remainder, you can pull out the tens digit, and then the ones digits will just be whatever remains after you divide it by 10. Then you build up the word, the result initially empty. If hundreds digit is not 0, meaning there is a hundreds digit, then you say the hundreds word plus the word 100. If tens digit is 1, so you might get 11, 12, 13, 14, so forth. Then you look at the teens word with the index of the ones digit. If it's not equal, if the tens digit is not equal to 0, then it's the tens word of the tens digit. So that's 20, 30, 40, 50, whatever. And then if the ones digit is not 0, then you put the ones word of that index onto the result. Strip it out so that you don't get spaces on the right and left. Possible they may have added these in somewhere. So strip that out. I have a bunch of test cases. Use those. See if it works. So 0, 1, 13 worked. So that teens thing worked. 20, 42, 100, 115, 200, 700, 42, 999. So it appears to work. I hope you enjoyed these problems. Yeah, thanks for playing along. I will see you in the next one.